So this is Unit 2 Progress Check FRQ question number 1. So this one, you can probably look at the picture and have an idea of what we're going to do. So read over the question, highlight major things. In this case, we got our negligible friction. That tells us no friction. That's important here. And yeah, so let's go ahead and read this. Actually, the first two questions are essentially asking to draw the FBDs. They do want you to draw the relative lengths, so make sure you notice that. And whenever you see kind of this grid pattern on the dots that they give you, that kind of tells you that you want the lengths to be relative. So let's look at number one. Number one, we essentially have gravity coming down, right? So we'll call that FG1. We have the normal force going up. We can call that Fn. And then block 2 is going to push down on this. So we can call this, I guess, the force of gravity from block 2 pushing down on it. Now notice, since it's in equilibrium, we want the two downward forces to be equal to the upward force. And then since block 1 is larger than block 2, we want to make sure that we draw that larger. So in other words, we could draw, let's draw this one is a length of 2. We'll call that FG1. And then we'll draw block 2. I guess we'll draw to the side here. This would be block 2. We'll call that FG2. And so notice this is the length of 2 units. This is the length of 1 unit. So we want the whole thing to be 3 units tall. And we'll call that the F normal force. This is coming from, I guess, the ground. I think we're good just sticking like that. So on block 2, let's go ahead and draw block 2 just to the side. So this one, we just have the force of block 2, force of gravity coming down, and then we have the normal force due to block 1 going up. So I think that's it, and these should be equal to each other. So you know what, I'm going to draw it the same as in the last problem just to stay consistent. So remember, FG2 we drew as 1 unit long, so let's write the F normal force going up. And again, if you want, you could put like in parentheses from block 1. I don't think it's necessary, but I'm going to do it anyway. So from block number 1 coming up. So the part 2 of this question, we are going to remove the block down here from the bottom and then analyze the question. So the first part says make a claim on what's going to happen to block 3. Well, remember, there was no friction here. Okay, no friction back here. So if all of a sudden we remove that block, there's going to be a net force, there's going to be some tension in here, and block 3 should start moving. So I think that's it. Just say those block 3 accelerates to the right. Okay, and again, because they want you to talk about unbalanced force, there's a net force due to tension from block 2 coming down. Okay. All right, question 2. We're essentially going to drive the acceleration in terms of variables. So let's go ahead and draw the FBDs here. We have the last one from the previous problem. Actually, it's changed a little bit, hasn't it? So this would be M2G coming down, and then we have our tension coming up. This block 3, I drew that already, and again, there was no friction. If there was friction, you would have to include that, but in this case, we're not going to. So yeah, then you're going to just do your FBDs. Remember, you want to define your acceleration in terms of like a direction here. So we'll call to the right positive, we'll call down positive. So we'll do that as we do our summations. So say for block 2, for example, we're going to go M2G minus tension equals M2A. And then for block 3, this one's just simply going to be tension equals M3A. Okay, because there's only one force. Again, if there was friction, you'd want to be subtracting friction from there. And then let's just go ahead and derive this. So we'll throw that T over here. So you get M2G minus M3A equals M2A. Okay, so you're going to go ahead and add M3A to both sides and distribute that out and then divide. So I'm going to let you worry about the algebra here. So we're going to go m2g divided by m2 plus m3 should equal a. That should be your final answer here. So question C, in what way is your question consistent with what you just derived? So hopefully you can see, well, you said there was an acceleration, and it is consistent, definitely consistent. It's not going to be zero. There's no way to make this have a zero acceleration here, so it has to move. So again, you can go ahead and explain that. You should not just say yes, but you can write that down. All right, letter D, we're going to go ahead and sketch this out. So the first thing to realize is that this acceleration is going to be constant. So since we define down as being positive, we're going to go ahead and draw a constant acceleration, so that should just be a horizontal line there. Note, you don't have to do this, but just conceptually, if this was g, 9.8, this should be less than that. And then we want to draw the velocity, so we started at 0, so we should be starting at 0, and then that's going to increase, in this case, in the positive direction, since we're defining to the right to be positive. If you flipped your directions and made little g, or made g negative down here, sorry, not g, but acceleration negative, then this would just be flipped. So in other words, I'll go ahead and draw this out. In other words, this would be negative, and this would be increasingly negative. So either of these, either the green graph or the red graph, should be fine. So that's it. Go ahead and grade yourself, see how you did, and let me know if you have any questions.